Greetings, Mr. Colazar's class. Today we're going to start looking at quantum mechanic model, and specifically what we're going to be talking about are where the electrons are at, giving them basically a street address. And so we call this our quantum numbers. Numbers assigned to each electron and where it's orbiting. Now remember, protons equal electrons, so your atomic number is the number of electrons you have. So if you had 10 protons, you'd have 10 electrons. So depending on what number you have is going to depend on how many electrons we have. Now an address, like you grow up in a house, you have the street address, and then you have the street, and then you've got the city, the state, the zip code. Electrons we're going to think of much the same way with our four ideas down below: the principal quantum number, the orbital quantum number, mechanical quantum number, and spin quantum number. It's a lot of information that we're going to be using in class over the next few days. So we'll just take this information down now, and then we'll be using it to understand over the next few days in class. So our principal quantum number is our first one, and it uses the letter N. And what it represents is the energy level of which the electron is in. Those numbers will vary: 1, 2, 3, 4, 5, 6, all the way up to number 7 is our last or the highest energy level that we have. So N increases as the orbitals become bigger. It's kind of like in our Bohr models. We had our nucleus, protons and neutrons, our inner nucleus, and then each energy level out from there as we're going is going to be a new orbital. Each one becomes bigger going outwards. Coincides with the periods or rows on the periodic table that represent each energy level. Electrons are considered to have lower energy when they're closer to the nucleus. Now we have the equation for the maximum number of electrons that can exist in each energy level. The electron maximum number is equal to 2 times n squared, where n is the energy level where we're at. So for an energy level 1, 1 squared is 1 times 2 is 2. And then for energy level 2, 2 squared is 4, times 2 is 8. 3 squared is 9, times 2, 18. And then we continue to move up. Now once we get past level 4, 32, the numbers go up in theory, but we don't have enough elements to actually fill these last few shells. Only in theory is where they fit in. So 32 is our maximum number of electrons that we actually can have. Our second quantum number is L. And so now we've went from the energy level that we're in to what we're going to call the sublevel or the shape of the electron cloud. The number of sublevels equals the number of energy levels. So our second letter, L, is the orbital quantum number. I'm going to have you write down real quick this acronym. Some people drive fast, and what it's going to represent is S, P, D, and F. Some people drive fast. It's just an acronym to help us remember these four letters, and it's going to be the sublevel or shape of the quantum, or excuse me, of our electronic orbital. So S orbital, P orbital, D orbital, and F orbital are those ones. So some people drive fast is going to be our acronym to remember that by. So what we're going to look at is the four orbitals. Now our four orbitals, the first one is the S orbital. On your page, make sure you write down that the S orbitals are spherical. And then part 2, they only have one orientation and 2 electrons can fit in the S orbital. Please include this part along with it being spherical. Now on your page, I've already filled it in, but on yours you've got an XYZ axis. It shows a three-dimensional representation on two-dimensional paper, since atoms are three-dimensional, and it's going to be just drawing a circle around that X, Y, and Z axis to show it's a three-dimensional sphere. So the S orbitals are spherical, and we're going to tell you now that a total of 2 electrons can go in that S orbital. Our second orbital are going to be known as the p orbitals. The p orbitals are going to be known as our peanut or dumbbell shaped orbitals. These orientations, or the way they're set up, is going to be that we've got along the xy axis, we've got our two orbitals. Along the y-axis, we've got another set of orbitals of where the electron can be placed at. And then a third set of orbitals, kind of peanut or dumbbell shape when you put the two together, along our z. So we've got in 3 dimensions, x, y, and z. These are where those electrons can be placed at. Now, one electron can be placed in each of these orbitals. So we can have an electron here, that's 2, 3, 4, 5, and 6. Up to 6 total electrons can fit in the p orbital. Now we have s and p, those are the two that you need to know. 2 electrons can fit maximum in the s orbital, and 6 total electrons maximum can fit in the p orbital. Now we do have 2 more orbitals. We said s, p, d, and f. What we need to know, the d and f orbitals, they're too crazy for us to worry about writing or drawing them out. Here are what the d orbitals actually look like, even though we're not going to draw them in. What you need to know about the d orbitals, just to write down d orbitals, 5 orientations, they can fit a total of 10 electrons in the d orbital. So 10 electrons total can fit in the d orbital. That's what you need to know. You don't need to worry about the pictures. And our f orbital, we're not going to draw these pictures out either. You can notice that we have 7 orientations, is what I want you to know about the f orbital. A total of 14 electrons can fit into the f orbital, 1 in each of the spots. So as we're going, f and d orbitals, too crazy for us. You just need to remember 10 electrons for the d orbital, 14 electrons for the f orbital. Our next quantum number, or as we continue our quantum number, n equals a number sublevel of the shape. So n in our first energy level, we only have the 1s, or they only have the shape, the name 1s. Once we get to the second energy level, we've got the 2s and the 2p. Once we get into the third, we've got the 3s, the 3p, and the 3d are going to be all option where the electrons can fill. And once we get to n to be 4, the 4s, 4p, 4d, and 4f. Now remember, the n, or the energy level here, is going to represent on our periodic table the rows on the periodic table. So as you go down the periodic table, we'll just draw out a quick periodic table. As you go down from a 1 row here to the next row, to the next row, to the next row on your way down, those are going to be represented 2, 1, 2, 3, 4, and continue on down as we're going. So the 1, the 2, the 3, and the 4 is what we're going to be looking at coming up. The magnetic quantum number is our next letter for describing where the electrons are located at. M, the magnetic quantum number, represents the orientation of the orbital, or which orbital in the sublevel are we talking about. So we have our s orbital. Remember, s can hold up to 2 electrons. Now both electrons have to be in the s orbital. In the p orbital, we can hold up to 6 electrons. So this is where it can change. The electrons can fit into each orbital. And we're going to look specifically where they fit in just a minute. And then in the d and the f orbitals, where we can put 10 electrons or 14 electrons, we're going to see that there are a lot more changes or places. We're not going to be concerned at which ones they fit in, just with the S and the P though. So our magnetic quantum fields, our quantum number, each orbital can hold up to 2 electrons. In the s orbital, number of orientations is 1. P orbital, there can be up to 3 orientations, 5 orientations for D, and 7 for S. Remember, each one of these orientations can hold 2 electrons. So for the S, 1 times 2, 2 total electrons can be held there. 3 times 2, 6 total electrons. 10 total electrons for D, 14 total electrons for any F level. And our last one, the spin quantum number, S is the abbreviation there. 2 electrons in the same orbital will spin in opposite directions, kind of like clockwise and counterclockwise, or up and down, where one would be spinning one direction and one would be spinning in the other, so that they don't actually run into each other. So as we're going, the spin quantum number, we're going to refer to a lot of times as upwards spin, kind of going up, or downward spin, going down. Last key part for this unit is just to remember these 4 terms. And our abbreviation to help you, to cheer you along the way, is POMS, like in pom-poms and cheerleading. POMS for POMS. P, principal quantum number. O, orbital quantum number. M, magnetic quantum number. And S, spin quantum number. Q, numbers, quantum number. Remember the abbreviation letter, L, or N, L, M, and S, and each one represents energy level, 1 through 7 on the periodic table. The second one, sublevel or shape, that's the S, the P, the D, or the F. The next one, the orbital orientation, is where at, not in the S, because the S can only be in one place, but the P, the D, or the F, where is it located? And then a last one is a spin, opposite directions. We have one spinning up if they're in the same orbit or orientation, and one spinning down. Please make sure you must know this chart.